Now in exercise 3b, we will talk about variable importance and how is variable importance measured for random forests and banked trees. So first of all, we will install the package, the random forest explainer, and import it to the notebook. And we use, or we set local imp to true, because otherwise we won't get the MSE increase when using measure importance later. So here we just build again a random forest model, or in this case it's a back model, as we set all the as we set the mtry parameter to 30, which means we use all the features when selecting our bootstrap samples. And here you can see that local imp is set to true. So now if I run measure importance and our input is our bagging model, we will get this return here, where we see different measures of variable importance for all the variables. And the professor already explained those quickly in the lecture, but I also denoted here the meaning of each of the variable importance measures. So mean min depth is the mean of the depth that every variable has when it's used for splitting. So for example, the failures here, which we know from last sessions, has a very high importance because it's ranked always at the top of the trees, has a very low mean min depth. So it's almost zero, which means that in almost every tree that we use, it will be used at the first split. So if you think about, we said that the root knot is of depth 0, and then the following knots are of depth 1, and so on. And just maybe go back to last session when I explained the min depth parameter for selecting the depth of a tree. Then the no of knots is the number of knots that a variable appears in. MSE increase is a measure for how much does the MSE increase when the variable is permuted. Please go back to the lecture and have a look what this actually means, because the professor described it in depth. And knot purity increase says how much does the knot increase in purity by the splitting this variable. The number of trees is just how many trees is this variable actually used in for splitting, and times a root says how often is this variable used in the root knot for the first split. So I think all these measures are pretty self-explaining, because if a feature is used in the root knot, it must be very important, because then it has a very high, it leads to a very good increase in improvement. And then the number of trees a variable is used in is also important, because if it's used in a lot of trees, then it means that in every case it was important enough to be used in the tree for splitting. And yeah, I guess all of them are very self-explanatory.